So there are three very well-known applications or well-studied applications for entanglement-based quantum networks. First is what we call quantum secure communications. So this is using the entanglement to securely communicate between 2 points on the network. I would say that's probably the nearest term application. There is what's called clustered or distributed quantum computing, and this is a use case where you're using the entanglement network to entangle different quantum processors, different quantum computers, and thinking very far ahead of when we talk about a quantum internet. If you look at the quantum computing space right now, you have big companies going after very different implementations of quantum computers. You have superconducting qubits, ion trap qubits, cold atoms, a bunch more. You're going to see photonic, maybe topological one day, but you have all these different implementations and architectures for quantum computers. All of them have pros and cons. Some are very fast, some are slower but higher quality. So you have different properties of these architectures. So in the quantum internet, what we're thinking about from an application standpoint for distributed quantum computing, how can we leverage these different architectures with entanglement? So if we connect a superconducting quantum computer from IBM to an IonQ quantum chip, what can we do with that if they're entangled, right? So there's that's another application, distributed quantum computing. The third one that's well understood is called distributed quantum sensing. So quantum sensors are probably the most mature quantum technology at this point. But the way they're done now is that these sensors will do local sensing, local measurements for their environment, and then you kind of post-process that data classically. But if you actually entangle quantum sensors, so you have an entangled quantum sensor array or an entangled network of quantum sensors, you can do more global measurements because you're entangled. So this can provide higher resolution, higher accuracy, has implications in position and timing and navigation. But this is another well understood use case. So those are the three most well understood is the secure communications, quantum computing, and quantum sensing. But like I mentioned before, there are many other applications that have yet to be thought of yet. So there's some cool ones recently thinking about can we use this for voting, secure voting? Can we think about blind quantum computing, where you can use this network to kind of secure your quantum data and your quantum algorithms. If you're going to send an algorithm with some key financial data or pharmaceutical data to a cloud vendor that has a quantum computer, say through AWS or through Microsoft or IBM, if you want to hide that data, there are some cool applications thinking about using this entangled network to do things like blind quantum computing. So there are many use cases like that and more to be thought of.